MCV4U1 Chapter 4 Curve Sketching, Session 7. In this session, we work on Section 4.3 from the textbook, Vertical and Horizontal Asymptotes of a Function. We know if the graph of a function is getting close to a vertical line, that at infinity, that vertical line is called the vertical asymptote of the function, and if the graph of a function is getting close to a horizontal or slant line, those lines are also called horizontal or oblique asymptote of the function. A vertical asymptote of a function is a vertical line for which limit of f of x as x approaches to c, if the line is x equals c, the limit is either positive or negative infinity. It could be from right side or left side. For example, we know limit of 1 over x minus c as x approaches c from right side is positive infinity, and limit of 1 over x minus c as x approaches c from the left side is negative infinity. Therefore, x equals c is the vertical asymptote of y equals 1 over x minus c. This is what we learned in previous course. A rational function in the form of f of x equals px divided qx has a vertical asymptote at x equals c if qc equals 0 and pc is not. For example, if we consider y equals x minus 2 over x2 minus 4, x equals negative 2 is the vertical asymptote of the function, and x equals 2 is not the vertical asymptote of the function, since both numerator and denominator is 0 when x is 2. If we consider f of x equals x over x2 plus x minus 2, the denominator is 0 when x is minus 2 or 1. Limit of f of x as x approaches 1 from right side is positive infinity. The denominator of the fraction is 0, the numerator approaches 0, and the numerator is a number. Both numerator and denominator are positive when x is close to 1 and more than 1, therefore the limit is positive infinity. In this chart, we see the limit of f of x as x approaches 1 from left side is negative infinity. When x approaches 1 from negative side, x is positive, x plus 2 is positive, and x minus 1 is negative because x is smaller than 1. This means f of x is negative, therefore limit is negative infinity. This is the way we see if the limit is positive or negative infinity. The graph of the function close to 1, more than 1 it is positive infinity, less than 1 it is negative infinity. Similarly, we can discuss it around negative 2. So if limit of f of x as x approaches c from either side is either positive or negative infinity, x equals c is called the vertical asymptote of the function. For example, if we consider y equals 1 over square root of x minus 1, limit of y as x approaches 1 from positive side is positive infinity. Limit of y as x approaches 1 from left side does not exist, but x equals 1 is the vertical asymptote of the graph of the function. One more time, if we consider limit of y equals x minus 2 over x2 minus 4 as x approaches 2, it is not infinity, it is 1 over 4. Therefore, x equals 2 is not the vertical asymptote of the function. Whereas as x approaches negative 2, from the right side, the limit is positive infinity, and from the left side it is negative infinity. Therefore, x equals negative 2 is the vertical asymptote of the function. We know the graph of the reciprocal function y equals 1 over x. X-axis and y-axis are asymptotes of this function. As x approaches positive infinity, the graph is getting close to the x-axis. As x approaches negative infinity, the graph is getting close to the x-axis. Therefore, limit of 1 over x as x approaches positive infinity or negative infinity is 0. To find the limit of px equals x2 plus 4x plus 1, if we factor x2, 4 over x and 1 over x2, when x approaches infinity, are getting close to 0. The denominator is getting bigger, the fraction is getting smaller. Therefore, limit of x2 plus 4x plus 1 and limit of x2 are the same. As x approaches negative infinity, for example, this limit is positive infinity. For polynomial functions, we say limit of p at x and limit of dominant terms are the same. Let's find limit of 2x minus 3 over x plus 1 as x approaches positive infinity. If we consider the dominant term of the numerator and denominator, we see the limit is 2. To show this in more details, we divide both the numerator and denominator by x. The limit would be limit of 2 times 1 minus 3 over 2x divided by 1 plus 1 over x as x approaches infinity. If we use properties of limits, this limit is the limit of numerator divided by the limit of the denominator. When x approaches infinity, 1 over x approaches 0. 3 over 2x is also approaching 0. Therefore, the limit is 2. Let's find the limit of g of x equals x over x2 plus 1 as x approaches infinity. If we factor x2 at the denominator of the fraction, the function can be written as 1 over x times 1 plus 1 over x2. The limit as x approaches positive or negative infinity is limit of x, the limit of 1 over the limit of x as x approaches infinity times limit of 1 plus 1 over x2 as x approaches infinity, the properties of limits. Limit of 1 plus 1 over x2 as x approaches infinity is 1. Therefore, lim of g of x as x approaches infinity and lim of 1 over x as x approaches infinity are equal. Limit of 1 over x, the reciprocal function, as x approaches infinity is 0. It could be positive or negative infinity. The next example, we divide both numerator and denominator by x2. P at x equals 2x2 plus 3 divided by 3x2 minus x plus 4 can be written as 2 plus 3 over x2 divided by 3 minus 1 over x plus 4 over x2. Limit of the function as x approaches infinity is limit of the numerator in the new form divided by the limit of the denominator in the new form as x approaches infinity. Since 1 over x, 4 over x2, and 3 over x2 as x approaches infinity are approaching 0, the limit would be 2 over 3. This means y equals 2 over 3 is the horizontal asymptote of the function. Next example. Determine the equation of any asymptotes, any horizontal asymptote of the function f of x equals 3x plus 5 divided by 2x minus 1. We find the limit of the function as x approaches infinity. We divide both numerator and denominator by x. F of x is going to be 3 plus 5 over x divided by 2 minus 1 over x. As x approaches infinity, we use properties of limits. We know limit of 5 over x and 1 over x as x approaches infinity is 0. Therefore, the limit of f of x as x approaches infinity is 3 over 2. To see if the graph of the function is above or below 3 over 2 at positive infinity, we find f of 1000. F of 1000 is 3005 divided by 1999, and it is greater than 3 over 2. Therefore, the graph of the function at infinity is above the horizontal asymptote to the right side, positive infinity. Next question. For the function f of x equals 3x over x2 minus x minus 6, determine the equation of all horizontal or vertical asymptotes. For vertical asymptotes, we set the denominator to 0, x minus 3 times x plus 2 equals 0, x is either 3 or negative 3. We find limit of f of x as x approaches 3 from left side, right side, negative 2 from left side and right side, and if they are infinity, which they are in this case, the corresponding line is going to be vertical asymptotes. Therefore, this function has two vertical asymptotes, x equals 3 and x equals negative 2. Let's calculate one of these limits. For example, x approaches 3 from the left side. When x approaches 3 from the left side, the numerator of the fraction is positive. The denominator is negative since x minus 3 is negative and x plus 2 is positive. Therefore, the fraction is negative, and limit of the function as x approaches 3 from the left side is negative infinity. To find limit of the function as x approaches infinity, we factor x2 at the denominator of the fraction. The limit would be limit of 3 over x as x approaches infinity. 1 over x and 6 over x2 as x approaches infinity are approaching 0. And limit of 3 over x is 0. Therefore, y equals 0 is the horizontal asymptote of the function. If a function can be written as mx, y equals mx plus b plus px over qx, when limit of px over qx as x approaches infinity is 0, then the graph of the function and the graph of the line y equals mx plus b are close to each other at infinity. Therefore, y equals mx plus b is the equation of the oblique asymptote of the function. For example, y equals 2x2 plus 3x minus 1 divided by x plus 1 can be written as y equals 2x plus 1 minus 2 over x plus 1. By long division, we can write the function in the new form, division statement. Since limit of 2 over x plus 1 as x approaches infinity is 0, y equals 2x plus 1 is the oblique asymptote of the function. If we look at the graph of y equals x plus 1 over x using a graphing calculator, we see the graph is similar to this graph. Y equals x is the oblique asymptote of the function. As we discussed, when x approaches infinity, 1 over x approaches 0, the graph of y equals x and the graph of the function are close to each other. Therefore, y equals x is the oblique asymptote of the function. In summary, we learned if x approaches c from right and left side, and the limit is either positive or negative infinity. X equals C is the vertical asymptote of the function. Y equals L is horizontal asymptote of the graph of f of x if limit of f of x when x approaches positive or negative infinity is L. And to sketch the graph of the function, what we learned so far is finding the discontinuity, determining any vertical asymptote, find the intercepts, both x and y intercepts, determine the critical points if there is any, use first derivative test to find out the critical points are either maximum or minimum, test the end behavior, which means find limit of f of x as x approaches positive or negative infinity, construct an interval of increase-decrease table, and identify all local extrema. Put all of this together and sketch the graph of the function. To understand the concept that we covered, next sessions we are working on exercise 4.3, question 1 part A, question 3 part A and B, question 5 part D, question 7 part C, question 9 part B, and question 10 part E. Thanks for watching.